Hello everyone and welcome to this introduction to machine learning tutorial. In this video, we're going to go through a binary logistic regression example for beginners. So I'm going to start this tutorial by explaining what is machine learning in a nutshell, and then we're going to go through the machine learning process. So all the steps you have to take when it comes to running machine learning models and all the tasks within each step. After that, we are basically going to follow this machine learning process step by step. So we're going to start with the problem formulation phase. So what are we trying to solve? What's the problem? Then we're going to move into data preprocessing. So exploratory data analysis, investigating our raw data, investigating relationships. Then we're going to do some feature selection. So selecting the most important features that actually affect our Y, our dependent variable. And then after that, we're going to split our raw data using the holdout validation technique. Afterwards, we are going to explain what is logistic regression, how it works, and how the maximum likelihood estimation works. Then we are going to train and run a logistic regression model and start evaluating our model. So going through the most important metrics when it comes to evaluating a logistic regression model. After that, we are going to do some hyperparameter tuning. So we're going to loop over some of logistic regression's hyperparameters in order to find the ones that give you the best performance. Then we're going to investigate some alternatives when it comes to running hyperparameters, when it comes to investigating hyperparameters. And then we are going to train a dummy classifier so we can compare that and use it as a benchmark versus our model. Then we are going to use those hyperparameters to train a new final logistic regression model where we're going to use to make some predictions. And at the very end, we are going to discuss how we can use this regression model in some real life scenarios. If you want to follow this tutorial through, I'm going to have a link in the description, which is going to take you into my GitHub repository where I'm going to have 3 files. The first file is going to be the raw data for this tutorial. The other file is going to be this notebook with the code. And the third file is going to be this notebook with just the titles, so you can actually practice the code while you're watching this video, which is actually the best way of learning. By the way, I would really appreciate it if you click that like button and subscribe to my channel if you are interested in machine learning and generally data analytics. Right, so in a nutshell, machine learning, and I'm coding now, is the science and art of programming computers so they can learn from data. And this was by Aurélien Giron's book, which I'm going to have a link in the description. Machine learning uses statistical models and algorithms to perform tasks like predictions and classifications without explicit instructions. So we take some raw data, we feed it into a machine learning algorithm. The algorithm or the model is going to learn from that data, and then we can use that model to make predictions on unseen data. Additionally, machine learning is a subset of artificial intelligence. Right, moving on to the machine learning process, the first step is the problem formulation phase. So here is where you're trying to understand and articulate what is the problem, what are you trying to solve. And a very good question here to ask yourself is, what is the Y variable? Is your Y variable revenue? Is it footfall? Is it volume? Is it spam emails? Is it churning accounts? Etc., etc. And after you identify what is your Y variable, then you need to gather all the raw data that is related to that Y variable. And while this step seems easy, it's actually very, very challenging in real life scenarios, as the raw data you will need will not be in one place like Kaggle competitions or online tutorials. It's going to be all over the place in the business, different departments, different databases. You're not going to have access to all those departments and databases. You're going to have to request access. You won't be able to set direct pipelines. In general, it's very, very challenging and time consuming. After you gather all the raw data you need, you're going to move into the data pre-processing phase. So here is where you're going to prepare your data to feed it into a machine learning model. So some of the tasks you might have to take in this step, these are not exclusive, is exploratory data analysis. So investigating relationships, observations, number of elements, null values, missing values, data cleaning, data aggregation, bringing your data together, so joining all the raw data. You might have to normalize your data, converting categorical features into numeric representation. You might want to do some feature selection if you have loads of features. You might want to do some feature engineering. And depending how well this data pre-processing phase is, so depending how well you do it, it's going to have an impact on the performance of your model. After you finish with the data pre-processing phase, you're going to move into the next step, which is splitting the raw data. The reason we split the raw data now is that we want to train our model on some data, a subset of our data, so let's say 80%, and then use the rest of the data, the rest 20%, to test our model on unseen data and see how well it performs on data that has never seen before. Here I have 70, 20, and 10 just because I like to train personally. I prefer to train my model on 70%, test it on the 20%, and then at the end, after finishing with the hyperparameter tuning, I finally test my model on that 10% totally unseen data with the best hyperparameters that I've selected. So this is going to make sense in a bit. The next step is to select and train your model. So if you don't know what model you're using already, you're going to have three options: classification, regression, and unsupervised learning models. Classification predicts a class, regression predicts a number, and unsupervised learning does not have a Y variable. It's just clustering or segmenting your data based on patterns. Some examples now of classification is the logistic regression analysis, which is the one we're going to be showing in this tutorial. Naive Bayes, decision trees, random forest, etc., etc. Some regression example is the linear regression, which was our previous tutorial, random forest regressor, support vector machine regressor, etc., etc. Some unsupervised learning examples is the k-means or the hierarchical clustering. Now, once you do select the model you're going to run, you're going to have to train your model based on the 70% training data that you have splitted over here. Usually, you don't just run one model, you run 3 or 5 models, and then you select the ones that have the highest performance, and then you move on to evaluate them and then tune their hyperparameters. After you train your model, you're going to have to evaluate your model based on unseen data. So you remember when we splitted the data in 70, 20, and 10, we're going to use that 20% now to evaluate our model. And we're going to use one metric or a number of metrics to evaluate our model. Different classifiers or different models have different metrics. Some of them have more, some of them have less. So now, some example of metrics is the R-square, classification accuracy, log loss, confusion matrix, precision, recall, mean square error, mean absolute error, etc., etc. After you finish with the model evaluation phase, you're going to move into the parameter or hyperparameter tuning. Some models now have these hyperparameters that allow you to tune them so you can avoid overfeeding your model on training data and also generalize your model as much as possible so it's going to perform well on totally unseen data. Some examples now of hyperparameters is the regularization parameter C, the number of neighbors, different distance functions, different weights, different distributions, penalty parameters, etc., etc. After you adjust the hyperparameters, you're going to have to train your model again and then evaluate your model on unseen data again. Then you adjust the hyperparameters and you train your model, evaluate it on unseen data again. And you keep repeating this process until you reach a point where you're going to be happy with the performance of your model on unseen data. And after you're happy, you're going to select those hyperparameters that you have identified that give you the best performance, train a new model based on those hyperparameters, and then test that new model on that 10%. You remember that total 10% we left out, totally unseen data, and see if you're happy with the results. If you're happy with the results, then you're going to move on and deploy the model. Otherwise, you go back into hyperparameter tuning and you start repeating the same process again. Right, so these are the steps you're going to follow when it comes to running machine learning. Now, I'm not saying you're going to exclusively follow these steps exactly. You might have to do some other steps too, some other tasks, but I would say about 90% of the time, this is the process that you will be following when it comes to running machine learning models. By the way, if you're getting enough value out of this video, I would really appreciate it if you click that like button and subscribe to my channel. Right, moving on to the first step now, which is the problem formulation phase. In this example, we want to investigate the factors or variables that affect a good loan or a bad loan. So we have some observations, some raw data, let's say, that have a column at the end, which is going to be the Y variable, and it says if the loan is good, yes or no, or good loan and bad loan. Hence, we want to make predictions whether a new customer should get its loan approved or not based on their characteristics. Therefore, our dependent variable is the loan approval, yes or no, or if the loan is good or bad, which is the same thing. We have good or bad in our raw data, but the way we're going to use it in the actual business is to say if the customer should get his loan approved, yes or no. So it's the same thing. It's a yes or no binary classification. Right, moving on to the libraries or packages we're going to be using for this tutorial. I'm going to be using operating system, NumPy, Pandas, Matplotlib, Seaborn, SKLearn, and Math. If you don't know how to use any of these libraries, I have explicit tutorials on each of those libraries. You can search my YouTube channel, you can find them. If you don't have any of this library installed, all you have to do is open the Anaconda terminal and type in pip install and then NumPy or Pandas or Matplotlib. If you don't have sklearn, then you're going to have to open the Anaconda terminal and type in pip install NumPy, SciPy, scikit-learn. Right, moving on to loading our raw data. To load our raw data, all we have to do is say raw data equals pd.read underscore csv, then open brackets, and then into quotations, we have to paste the path that you have downloaded the raw data. So after you download the raw data from my GitHub repository link in the description, then you go into the folder that you have saved it, you click on the path, you copy it, and then you go back into your Python code, you paste it into the codes over here. We want to use a double forward slash, so make all those doubles. And here at the end, we want to add the name of the file. So if I go back into the folder, I click on the file, I copy the name of the file, then I paste it back into here, and then I say .csv at the end, and I just run it. I get an error saying PD is not defined. It's because I haven't run my libraries. So if I run my libraries again, it's the first time, that's why it's still loading. Then I run this one, it worked fine. Now I want to print the shape, so I can say print row, oh my god, row date. That's going to be row data, sorry. Copy this, paste it, and then say shape. Then I also want to run the first 5 rows, so I'm going to click the raw data, copy, paste it, and say head, and then put 5 in here. If I don't put 5, it's going to be the same. So we can see we have a total of 106 observations or rows and a total of 14 columns. And just to go over the columns now so we can understand them, we have the type of the account, we have the account history, we have the reason for the loan, we have the loan amount, so how much they requested, we have account savings, how much money they have saved, the employment history, the visual status, and then some other features over here you can see. And at the end, we have the good loan, which is going to be a yes or a no. So this is going to be our Y or dependent variable that we are trying to predict. If it's a good loan, a yes, what I was saying here at the beginning, then we're going to say then the loan is going to be approved. If we predict that it's going to be a bad loan, then we're going to say the new customer's loan is not going to get approved. Right, moving on into data preprocessing now. The first thing I always do in this step is to investigate if I have any missing data or null values. And to do this, I can just copy and paste my data frame. And let's say .isNull, and then open brackets. If we run this quickly, we can see it says false, false, false. It means it's not a null value. The way to get a summary of the null values, you can say .sum at the end. Then if I run this, we get the null values per feature, as you can see. So we have about 2 null values in the feature type of account. We have 5 null values in employment history, etc., etc. The next thing I want to do is to visualize these null values just to see if I'm able to fix them. And I'm going to explain this, how it works later. So first of all, to visualize the null values, I can just say raw data, open brackets, raw data again, and then into codes, I'm going to select the highest number. So I'm going to start with employment history, and I'm going to say .isNull. Then do I need the brackets? I think I do. If I run this, employment history is with a space. There we go. So 1, 2, 3, 4, 5 observations, which is these 5 observations that have null values. And as you can see, the first observation only has data for the first 3 features. Then it has no data. The second one, it has data for the first 4 features, no data. This one has data over here, and then the last one has data over here. So as you can see, we cannot fix these ones. We just have to remove all of them. But in some cases, let's say you had all the data and the only thing you are missing was age. What you could do if you didn't have enough observations, you could replace the null value here in age with the either average, either median, either the previous value. So these are some techniques that you can use to replace your null values if you don't have enough raw data. But as you can see here, there's nothing we can do with these ones. They are missing more than just one feature. So what I'm going to do is that I'm going to delete those null values. So all of these null values. To delete the null values now, I have to copy and paste my raw data, my data frame, and then say .drop NA. And then if I run this, it's going to work because it's going to drop all NA from all the data frame. If I want to select a specific column, I can just say subset equals, and then here I can put the employment history. So we gotta be more careful what we drop here. And then if I run this, it returns the data here. So I actually have to pass it back into the data frame or say comma in place equals true. I'm not entirely sure that works, but you can try it. Then if I run this, we can see it works. If I print the shape now, I can say print and then raw data.shape. If I run this now, we can see we have 5 less observations. So when we initially brought the data, we had 1006 observations. Now we have 1001. That's because we dropped all these 5 observations. And then we also want to rerun our null check over here just to see if we have more null values in different columns. So as we can see, because all the null values were within these 5 observations, we don't have any other null values. Right, the next thing I want to do is to investigate all elements within each feature. So I want to write a code that loops over all the features and investigates the number of unique elements. And if those unique elements is less than 10, let's say, print those unique elements to see what's in each feature. To do this, I can say for column in and then my data frame. So I'm going to say raw data. I want to calculate the unique values first. So I'm going to say unique values equals np.unique and then open brackets. And here I need my raw data first. And then I need the column, the first column, because I'm going to go through all columns. Then I need the number of values. So number of unique values actually. So this is going to be the length of unique values. And next, I want to say something like if the number of values, so the unique number of values is less than 10, then I actually want to see them. So I'm going to say print, and I'm going to say the number of observations for feature. So the number of values, not observations. What am I saying? The number of values for feature, and then I need the first feature. Then I'm going to say is, and then I'm going to put the second. And then I also want to print the unique features because this is if it's less than 10. I'm going to explain this in a second. I can say format, and here is where I want to print, first of all, the feature, which is going to be the column. So this first column corresponds to these first brackets over here. Then I want to print the number, the unique values, so number of values. And lastly, I do want to print the actual values if it's less than 10. So this is going to be the unique values. And down here, I can say else, and then print the same thing, the number of values for feature. And then I want to remove the last thing because this is going to be too long to print, and remove these two. So if we run this, we have our output, which is basically saying the number of values for feature type of account, which is the first one, is, we can see that we have 4 values, distinct values. I can actually say distinct values in this first feature, which is the no data, type A, type B, and type C. Going to the second feature, which is account history, we can see that we have 3 unique values, which is the average, known delays, good, or critical. The third one now, which is the reason for the loan, is 10. And because it's 10, we have less than 10 is only printing the column name, which is the reason of the loan, and then the number of values, which is 10. If I actually say 11 here, or less or equals, and run this, we can see that it actually printed all the reasons now, which is the advanced education or training, all other, buying new car, buying a used car, home devices, home furniture, etc., etc. Then the number of values for feature loan amount. So this is 911. And then we have the number of features of account savings. We have 5. And then we have all the data: 5, 5, 2, 4, 57, 3, 4, 2, and then 2. This is the good loan. This is our dependent variable. We can see when we have yes and no, if it's a good loan or if it's a bad loan. So what we can see from here is that we only have two numeric values, two numeric features, which is the loan amount and the age. Everything else is categorical, so we're going to have to somehow turn our categorical features into numeric representation, which is going to help us use it into the algorithm, which I'm going to show later on in this tutorial. What I'm going to do is to investigate the relationship of loan amount and age, just because it's only our two numeric features. Also, we can investigate if they have outliers by viewing the scatter plot. To do this, I'm going to use a pair plot actually, which is scatter plot. So I'm going to say g equals sns.pair_plot, and then into brackets I'm going to put the whole data frame. This is going to work because this is only going to select the numeric features, which is loan amount and age. And as we can see, because we have this one outlier here, it skews the whole data and we cannot really see what's going on. So we have this number here that has a loan amount of minus, I don't know, 5 or something. And then it has an age of 300 years old, which is impossible. So what we have to do is to do some data cleaning, delete this outlier we have identified, and then visualize the data again. Right, to delete the outlier, I need to select the outlier first. So I'm going to start by selecting the age outlier. So I'm going to say row data, and then select all the data that has an age more than, say, 100. And if I run this, we can see this one outlier here that has an age of 327. So this number is actually 327. And we can see it's the same outlier for the loan amount, because it has a loan amount of minus and then a massive minus number. What I have to do is to remove this outlier and rerun my pair plot again. To remove the outlier now, I'm just going to copy the raw data and pass the data back into the data frame, and also switch this more than 100 to be less than 100. So this is going to select everything else and pass it back to my raw data. So if I run this now, we can see it worked fine. And also if I print the shape just to confirm, we can see we have 1000 rows now. So before we had 101, we removed 1. Now we have, not 1001. Now we have 1000. Now I'm just going to copy the visualization from up here, the pair plots, and run them down here. Notice, see how we have a crossover between exploratory data analysis and data cleaning. This is very common when you're running machine learning models, because sometimes you have to clean your data, then go back, visualize it again, and then come back, clean it again, etc., etc. So there is no right way of doing things. You just have to do them in whatever order it makes sense to you, or the one that is more convenient for you. Right, so what we can see now is the distribution of age is a bit right skew. The distribution of loans, we can see the majority of our loans are smaller loans. And then we have the loan and age, and then we have again, the same thing, the loan and age. Additionally, I do want to add the hue here, which my hue is going to be my Y variable, just to see if there is a relationship, or we can linearly separate them, which is the good loan. So if I put this here and then rerun it, we can see the good loan, no, and yeses over here. So what we can see is that when the loan is more, so as long as loan keeps increasing, then we have more no's than yeses. So I think it's going to add some value into our logistic regression model when we pass age and loan into it. But we're going to find out later on when we do the feature selection, just to see how much importance loan amount and age adds to our y variable, which is going to be the good loan. Yes or no? Right, since we've passed 20 minutes now, I'm going to stop this tutorial here and finish the rest of the tutorial in the next video. If you feel that you're getting enough value out of this video, I would really appreciate it if you click that like button and subscribe to my channel. Additionally, you can enable notifications so you know when I'm going to upload the next video. If you have any questions about this tutorial or there is something you want to say to me, please let me know in the comments below. Otherwise, thank you very much for watching, and I'm going to see you in the next video, which is going to be in 5 days' time. Thank you very much for watching.